Section 4.4 looks at linear inequalities in two variables. So what we'd like to do is graph the solutions to the inequality given here. In the first one, we have y is greater than or equal to 1/2 x minus 3. There's two parts to this inequality. We have the greater than part and we have the equal to part. We know how to do the equal to part. So let's just for a moment consider y equals 1/2 x minus 3. This graph is a line, and it's a line whose slope is 1/2 and whose y-intercept is the point 0, -3. So let's go ahead and graph that line. And so here is that line. Notice that our y-intercept is at y equals -3, and the slope is 1/2, which means from this point we go up 1 to the right 2, up 1 to the right 2, as many times as we wish. So all the points on this line satisfy the equation y equals 1/2 x minus 3. So the only thing we need to discuss is how do we graph the points that satisfy the greater than part? Well, this basically involves shading, and we're going to shade either above the line or below the line. And we have to make sure we do the right one. So there's two ways to determine where to shade. One thing you could do is you could pick a point, a test point from either region, plug it into the inequality to see if it's true or if it's false. If it's true, then you would shade there. If it's false, then you will not shade there. But there is actually an easier way to do this. Y represents the y-coordinate of a point. And what we're saying is the y-coordinate of the point is greater than or equal to the line. And since the y values are vertical values, y gets greater as we move up. And so if y is greater than or equal to this line, it means we're going to shade above the line. So we don't actually have to get a test point. We can simply use the fact that greater than means you shade above the line. Now, to be really specific here, in order to use this method for graphing, you need to make sure that y is all by itself when making that decision. Let's look at the second problem. So here we have 2x plus 3y is less than 12. This problem will be done very similarly. However, notice there is no equal sign there. So what that means is that when you graph the line is actually not part of the solution. So what we do in this case, when there's no equal to, is we graph the line as a dotted line. So just like before, the first thing we need to do is we need to determine what does the line look like. Now there's two ways we can go about doing this. You can get points on the line, or you can solve for y, like we had here, and then use the slope and the y-intercept. I like that method better, so that's actually the way I'm going to do this. So I subtract 2x from both sides, and this will give us 3y is less than 12 minus 2x is the same as -2x plus 12. And then I can divide both sides by 3. And when we do that, we get y is less than -2/3 times x plus 4. And so this line has a slope equal to -2/3 and a y-intercept of 0, 4. So we just need to now graph the line that has a slope of -2/3 and a y-intercept of 0, 4. So let's bring in that graph. So here's the line that has the y-intercept at 4, and the slope is -2/3, which means we go down 2 units and then to the right 3 units, down 2 units to the right 3 units. And so you can see that pattern there. Notice the line is dotted, and that's because we don't have equals, so the line is actually not part of the solution. But we need to determine which side to shade on. Do we shade above, or do we shade below? Well, the direction of the inequality gives us this information. So since y is by itself, and it's less than, we know y gets smaller as we go down. So for this reason, we'll be shading below the line here. And so this is what the solution looks like for that inequality. Let's try one more. So here we have 5x minus 2y is less than -10. So just like we did in the other problem, I'm going to solve for y first. So I subtract 5x from both sides, and this gives us -2y is less than -5x minus 10. And then I'm going to divide both sides by -2. And I'm doing this in red because when you divide by a negative, you have to remember to reverse the inequality. So this becomes y is greater than +5/2 times x plus 5. And so now we need to graph a line which is dotted. So the line will be dotted because, again, we don't have equals here. The slope of the line is equal to +5/2, and the y-intercept is 0.5. So let's go ahead and graph a line that has those properties. So here's the graph of our line. Notice the y-intercept is 0.5, and the slope is up 5/2, which we actually can't see going this direction. But remember, if the slope is 5/2, that's the same as -5/2, which means down 5, left 2. And so from the y-intercept of 0.5, we can go down 5 to the left 2, and that's our other point on the line. And then we graph a dotted line through those 2 points. Now, where do we shade? Now you have to be careful here, because the original inequality was less than. But when we solved for y, the inequality was reversed. This is the inequality that matters. So if y is greater than the line, that means we need to shade above the line. All right, that pretty much concludes this section. It's a very short, quick section on graphing linear inequalities in 2 variables.